Okay.
Yeah.
I'll take it. Thank you. That was kind. Okay, I want to talk also about applicatives because I think they're really cool. But sort of more in terms of a practical problem I had. So together with Florian, I'm writing this server-side Swift app. And we have a bunch of endpoints there. Our server exposes things. For example, there you could do like, for example, a GET request to get all products, and it will return you a JSON array with all the products in it. And you can also do a POST request. Let's say you want to, I don't know, post a user, and then you get on the server you get some JSON in that you need to parse, and you need to turn that into a user struct. And well, this talk is a little bit about JSON parsing, so I'm sorry. What I want to do at the same time is generate the documentation for that parsing. So, you know, like you want to say, well, okay, this endpoint to post a user, it expects a name which should be a string, and let's say it expects an ID which should be an integer, and then we want to have constraints maybe like that integer should be non-zero, and that name should not be empty, or the email should contain an @ sign. So the question is, how can we achieve that? Like, sort of make sure that this endpoint and the documentation always stays in sync. Because I'm pretty lazy. Like, I would write the parser and then document it, but then, you know, I'll change the parser and forget to update my documentation. So that's sort of the challenge for today, to write something which allows us to write the parsing and the documentation at the same time, and always make sure that they stay in sync. So let's see how we can do that. The first thing, we'll first need to build a little bit of infrastructure, so that's what we'll start with. So the first thing, let's define what a JSON dictionary looks like. So a JSON dictionary is a dictionary which has strings as the keys and then any as the values. So this is what comes out of JSON serialization in Cocoa. Now, we need to specify sort of the parameter type of the parameters we expect. So that's the first step. So I'll call this parameter. I don't know I don't know if this is the best name, and it's for most of my presentation. So please help me later on, maybe with better naming. So a parameter basically contains an API description, which we want to render to the user, and then it contains a parse function. So parse tries to take an any and tries to construct an A out of this. I'll make it optional. We should really be using throws instead of optional so that we can have good error messages, or maybe use result or something like that. But for the sake of the presentation, we'll use optionals. Now let's define two parameters. So we can say, well, a string parameter is a parameter of type string. And for the API description, we just say string. And for the parse function, we just check if this is a string. Okay. Now, an int parameter is almost the same thing. So for the API description, there we go. We'll say integer. So this is sort of user-facing documentation. For the parse function, we'll say this has to be an integer. Let's see. Okay. So now the next step, and this is sort of expressing a way to name parameters. So we want to, for example, say, well, there's the email parameter, which has to have a key email, and it has to have a string, has to have string as its type. So I'll call this named parameter, and in here we'll have the API description, which is a string. So this describes sort of that key. It has a key, which is also a string. And then it has a parameter inside. So now we can construct two of these values. So actually, let's use Steven's example because it was nice. So we can have an user with an ID, which is an integer, and let's say an email, which is a string. Now, we can construct two of these named parameters for the user. So we can say let ID equals named parameter, and we'll say the user ID, or actually maybe just the ID, something like that. For the key, we'll use ID, and for the parameter, we'll say this has to be an integer. See if the compiler is happy. For email, we'll use a name parameter, and as the API description, we'll say the email address. For the key, we'll use email, and for the parameter, we'll use a string. And I think it's important to explicitly have these keys sort of as strings in there. So maybe like in your API, you want to expose this ID as something like ID thing, like with underscores. But in your struct, you want to have camel case. So that's why we explicitly put them in instead of using something like a mirror. So now is basically the big challenge. So how do we combine these named parameters? And to use that, we're going to write something called a dictionary parser. This is the name I'm most unhappy with. But let's call it dict parser. So a dict parser of an A, basically, it will store all the keys and their descriptions. So to do that, we'll store API descriptions. And this is just going to be string to string. So for all the keys, it stores the description. Now, the other thing is it needs a parse function. And this parse function is going to take one of these JSON dicts that we defined and going to try to produce an A. And, well, we could construct a very simple dict parser from, let's say, one named parameter. And to do that, we can just add an initializer. So we can say dict parser and add an initializer where we take, let's say, P, named parameter, A, and this is sort of the A from the definition. Now, over here, we can say, well, the API descriptions, that's pretty simple. We have to say p.key and then p.api description. And for the parse function, now we need to define a function, so we get a dictionary in, and we need to look up that key in the dictionary. If it's there, we can continue, and if it's not there, we have to fill out. So we can say something like if let value equals dictionary p.key. If we cannot do this, we'll just return nil. We cannot parse. Now that we have the value, we can take the parameter and use its parsing function. You can say p.parse and pass in the value. And it's actually p.parameter.parse. And let's return that. Guardlet, yes. I made this mistake during practice as well. Florian corrected me. Should have known. Okay, I think it should be happy now. Yeah, so let's see how we could use this. We could create a dict parser from the ID, and now we should be able to parse a dictionary with just a single key in there, the ID. So let's call this endpoint. Very simple endpoint. We can say endpoint.api descriptions. Hopefully. Let's print that, actually. Always useful. So here we see that we have one key and a description of that key. And we can also parse. So we can say endpoint.parse. Then we pass in a dictionary, let's say ID with 5, and it will parse, hopefully, that 5. So I'll dump that. Okay, there we go. So if we misspell the key, it will return nil. And let's fix these API descriptions because we actually want to show that this ID should be a string. So I'll actually duplicate the initializer, and there we can append it to strings. So we can say init, API description string, key string, parameter of A, self.api description equals, and here we can use string interpolation to use the two API descriptions. So we can say API description and then use the parameters API description. This is still a little bit boring, right? key equals key, self parameter equals parameter. Okay, here we go. So now our API description or our documentation should be a little bit better. There we go. So now it says ID has to be an integer. And sort of you can imagine how instead of generating a dictionary, you could have like nicely formatted HTML or something. That's not the point of the talk. If we would have used a dict parser with name instead, then we can parse a single key or a dictionary with a single key name. Email, yes. Thank you. So now we can put in an email. If we put in 5, it's not going to parse because it's an integer. And only when you say hello at test, it's going to parse. And now comes the big question. How do we combine sort of either like dict parsers or dict parsers with name parameters, or how do we combine name parameters? And this is where we have a couple of options. So one solution would be to use some array of named parameters and then try to construct a user from that. But then we lose type safety, because how do you know that all the keys are there, and like how do you know that everything matches up and the types match up? That becomes really difficult. And it turns out that applicative functors are a really great way to solve this problem. So thanks to Stephen for introducing those. And yeah, we now know that we need to do a couple of things. So the first thing to sort of have an applicative functor is to have a pure function, so we can actually do that. And I'll make dict parser an applicative functor, and instead of like a top-level global free function, I'll use an initializer. So let's have a pure value of type A. And well, we don't need any API description for this, so we can just say self.api descriptions equals the empty dictionary. And for the parse function, we can basically say, well, whatever you put in, I'm just going to return that value. And now we need an apply function. And I think the reason why it's called apply is if you would write an operator like this, which takes sort of a regular function from A to B, and then it takes an A, it produces a B. And it's called applicative functors. I think the applicative probably refers to that apply. So what you do is basically you wrap everything in that functor. So you say, instead of A to B, you say dict parser A to B. And instead of A, you say dict parser A. And over here, you say dict parser B. So you basically wrap that apply. So this has to have a label. And we'll probably need to define that operator. Infix operator. Let's call it apply. And then we define one of these precedence groups. This used to be a lot easier. And we have to specify the associativity left. There we go. And we need the generics. Thank you. OK. So here we go. Now, this is what a real apply function should look like. I'm going to take a shortcut. And again, just for the sake of the presentation, and instead of saying, well, a dict parser from A to B, on the right-hand side, I'm going to take in a named parameter of A. That's going to make my life a little bit easier and make me able to finish the presentation in reasonable time. So we know the result. We have to return a dict parser. And we can look at the initializer. It takes basically these API descriptions and a parse function. And for the API descriptions, well, we can take the API descriptions from the left-hand side and basically add that one key from the name parameter. So let's say descriptions. So I'll use mutability. I love it. So we'll take the API descriptions, we'll append the key. So we'll say right-hand side.key equals right-hand side.api description. And now we can use that over here. So in our parse function, we need to take in this dictionary, and we need to somehow come up with a B. And, well, there's not much we can do. So the first thing is to say guard-let function equals LHS.parse. And this will give us a function from A to B, hopefully. So we can pass in a dict. Otherwise, we return nil. Now, for the right-hand side, it's a little bit more effort, right? Like we need to check in the dict if the key exists, if we have a value, and then we pass the value on to the parse function. So we can do something like guard-let value equals dict right-hand side of key. Otherwise, we return nil. And now we can call the parse function on the right-hand side. So we can say guard-let favorite name x equals right-hand side dot parameter dot parse. Put in the value. Otherwise, we return nil. You can easily fold all these cases, of course. Now we have an f, we have an x, and we can just apply them. So return f of x. Seems to be happy about it. And now let's think about how we could use this. And this is, I think, it always takes a little bit of getting used to. And the way I think about applicative functors is if you read something where you would normally write user ID, ID, email. So for every comma and for every parameter, for the initial parameter, you have to sort of replace those two things with the apply operator. So over here, we'll have an apply operator, and over here, we'll have an apply operator. So, of course, this is very invalid Swift syntax, so let's do it right the first way. So we have to have like some kind of sum function, which constructs the user. Then we want to have the ID, and then we want to have the email. And this sum function is, like Steven showed, sort of the curried version of creating a user. So we call this, let's call it make user, and we'll say let make user. Let me just, yeah. So let make user is a function which takes an ID and an email and returns a user with the ID and the email. And we need to create a dict parser out of it. So this is sort of the pure thing we need to do. And there's a brace missing. Oh, yeah. So let's call this one endpoint and remove our old one. And add an equal sign. Always good. Love them. So the type of this endpoint, if we look at it, hopefully Xcode will show us, is a dict parser of user. So we just know that we're going to get a user out of this. So first, let's do endpoint.api descriptions, and hopefully we'll get a nice, good API description. And print that. OK, so now we know if we generate our documentation that we have to have an ID, which is an integer, and we have to have an email address, which needs to be a string. And the keys are in there, so this should be fairly easy to produce on the client side. And we can also parse. So we can say endpoint.parse and pass in a dictionary. So if we do an empty dictionary, we'll get nil, hopefully. If we say something like email, here's a test, and ID 1, we'll hopefully get a successful user. Awesome. So we're not done yet. We're not done yet. There's still a bunch of things to do because we want to have this validation. So we want to say, well, actually, email needs to contain an @ sign. And this is actually fairly easy to do. So we can do something that's, I guess, similar to filter. So let's say extension parameter. And we're going to add a method which takes like a method check, which takes an API description, which is a string, and it also takes a function that checks. So let's say Eidhof. And then let's call it this one condition. Then it returns a new parameter of A. So how do we implement this? Well, it's not very hard. We return parameter. And for the API description, again, we use string interpolation. So we say self.API description. And then maybe, I don't know, a comma or something, and use the new API description. For the parse function, we'll get a value in. The first thing we need to do is try to parse that value. So we can say self.parse value, do a guard let. Otherwise, we return nil. The other thing we need to do is actually check if the condition holds. And we can just say condition result. And we'll need to add an escaping over here. And finally, we need to return that result. So let's add some checks. Now, I'll clean up the code a little bit. I'll move this code down so that we have our library and our application code separate. App code. Comments are always great. So let's say we want to check that the ID is larger than 0. So we can say int.check. We say non-0. And for the condition, we just check that $0 is larger than 0. So now we changed our parser, and we were forced to also change our documentation. I mean, there's always ways around it if you want to, but you're basically preventing yourself from making the mistake of forgetting to update the documentation. Our parser still works. We can see that in the documentation, the integer now has to be non-0. If we actually try -1, the parsing will fail. Okay, so one last thing, and that will hopefully also clean up the code a little bit, and that's to add the support for optional parameters. And first, we might think to add an extension on parameter, just like we did before for checking. But that's not really going to work, because parameter says string, but for an optional parameter, we sort of want to say, well, this key is also, it's also okay if this key is not present. And in order to build that, we need to refactor a little bit. And we're going to actually build this on top of named parameter and not on top of parameter. And to do that, instead of storing the parameter, we're going to store a parse function which takes a dictionary and just tries to parse that one named parameter. So if you remember, parse looked like this. It took a JSON dict, and it tried to produce an A. And now over here, we need to say self.parse equals. And actually, we already implemented this. This was in our initializer for dict parser. So that's basically this code. So I'll cut that out from over here, paste it back over here. And here we can also see that it is the correct place, because now we can remove all those p dots. So dict key, parameter.parse, and I think the name parameter is now okay. In our dict parser, now here we can just say p.parse. And this also cleans up nicely. So here we can now, instead of saying f value in x, we can just say guard let x equals right-hand side dot parse. Hopefully. I think I still made some kind of mistake. Ooh, line 25. What's that? No, I don't think so. Expected expression in assignment. Does anybody spot it? I don't. I didn't practice this part. This looks okay. This looks okay. Okay. 38. Sorry about this. Okay, let's And this doesn't work. What happened here? What's that? How much there? Okay. Restart Xcode.
Stop and play the program. Stop and
I don't know if it's probably my mistake. Well, maybe that's the problem. My computer locked up somehow. I quit Xcode. Oh, that's okay. I don't mind. Okay. Seems to be happy about this part. Now let's do the scary part. Was it really Xcode? Was it? Does anybody have connections? I think it was.
Value doesn't exist.
I mean, it was a good error message, right? At least. Okay. So what we did, just because maybe you got distracted now with all the curly braces and stuff and the value. What we did is we moved sort of this dictionary parsing from the dict parser into the named parameter. And now we're almost ready to write optional. So we can take our named parameter, and now over here, we can write optional. And this is going to be a named parameter of optional A. So we need to return a named parameter of optional A. We need to help the compiler a little bit. In our API description, we just say self.api description. And actually, let's make sure that we, in the documentation, also say it's optional. Optional. And for the key, we use self.key. And for the parameter, now, we need actually the parse. So we need to provide the parse function instead of the parameter. So let's move this into an extension so that we can keep the member-wise initializer. Named parameter. And now we can hopefully use the parse function. So this will take a dictionary in. And here, if we cannot find the key in the dictionary, we're just going to return success. So we can say guard let value equals dictionary self.key. Otherwise, instead of returning nil, we're going to return sort of successfully nil. So some nil. If we do have a value, then we want to actually parse it. So we can say self.parse value. Self.parse dict. Okay. So for some reason, this is not parsing. Now, this will still parse. We can add, let's say, for example, address, which is an optional string. Now, to do that, we can take our email parameter, copy paste it, say address. Over here, we say the street address. And it needs to be a string. And then we can make this entire thing optional. Oh, and one really cool thing to note is that now our entire app doesn't compile anymore because we added this address property. So we're forced to fix these errors. So over here, we have to say address in, and add it over here. And hopefully now, I keep doing that, right? So now the interesting thing is that it compiles. And here you can really see this applicative thing. So if you think about it, this endpoint is now, instead of providing us with a user, it's providing us with a function that still wants that optional address. If you would type it like this, big parser user, then we get a compile error. So we need to still provide that address over here, and now it's fine. So we can leave up the address with nil, and if we put it in, it's going to parse. And if at any point we want to take away one of these properties, we will get an error. If we forget to mark optional over here, it will compile because of optional promotion. But if we say, well, okay, address is optional in our parser, but let's say we forget to add the optional over here, now it doesn't compile because where you're going to supply this make user with an optional address, the types just don't match up. So I think this is an interesting way of using applicative. So by combining sort of the parser and the documentation generation, you're forcing yourself to always have correct documentation. And with any condition you add, or with any optional you add, you're basically changing the documentation automatically. And you can actually use this for other stuff as well. So I think in Rollstock, the GraphQL stuff, you could do something similar there, where you sort of parse the GraphQL result and generate the query at the same time. I think that could be very interesting, and you could also use applicatives there. That being said, I think I'm through my presentation, and I'm happy to take any questions. Thank you. Yes, Brandon.
I don't know if you've thought about this, but now that we've seen that, like your condition, your check condition, right? That's a predicate.
Yeah.
It's for monoids play applicatives. Could probably still conditions as individual predicates that describe like one single condition, then monoidally concat them together and instantly generate a list of conditions from that, rather than like say that condition was starting to have a bunch of different stuff like that. You could generate all those like at the atomic level.
Absolutely, yeah. That would be very interesting, yeah. Any more questions? No more questions. Okay, then let's thank the speaker. Oh.